Well, hi guys. Welcome to one more edition of the IPM Booster lecture series. Today's topic is calculus, and we're going to look at differentiation and integration. In one previous lecture, we've already taken a look at limits and continuity. And so today we'll try and understand calculus a little more. If you're joining our channel for the first time, then please make sure that you like, subscribe, and share our videos. Another important point is that all the exercises that we'll be discussing are available for you to sort of view. Just click on the link in the description and you'll be able to register for free and be able to access these exercises. Right. So on to today's session. Good evening to our live viewers. Hi Siddhant, hi Kriti, hi Anshuman. In the last class, we discussed a topic which probably is very, very relevant for IIM-Rohtak. I think in the new format, I'm not sure if you're going to get too many hard questions or not, but definitely what we did last time was some tougher pattern of questions from clocks and and time, speed, and distance, and also cubes actually. Hi Rishita, good evening. Right, so hopefully everybody is able to access the exercise for today's session. I'm going to pull up the exercise in front of me so we can start our discussion for the day. Again, goes without saying, most of these questions are similar or of slightly higher variety in terms of difficulty as compared to your CBSE exams, but the general word of advice remains the same to all IPM aspirants. Do not try to attempt very, very hard questions. If it is a question that you've never done before, then you're probably better off leaving such a question in the actual exam. As far as practice goes, I think the sensible option is to try and learn. If you don't already know the solution, then try and learn how the question gets solved. Because goes without saying that attempting a few tough questions in a competitive exam, especially one like IPM, could just give you those extra few marks to clear the cutoff, right? And that's something that we all should be looking forward to doing. Right. Before I begin today's session, a short announcement. Tomorrow, I'm going to conduct a live session on the WAT. Because IIM-Indore has already announced that they're going to do a online WAT section. So I thought it would be a good time to sort of revise, what we've learned on WATs and try and use some of those learnings on a few topics. So do attend the live session tomorrow. That's going to be from 6 p.m. Like usual, right? So 6 o'clock to maybe an hour and a half. That's what I have in mind. Yeah. So specifically the WAT section, so it would be useful definitely for IIM-Rohtak, but also for Symbiosis and later exams. Okay, I have a question here from Kriti. She's saying, how do we prepare for business awareness for the DU-JAT? Okay, it's a very good question. DU-JAT traditionally has one section dedicated to business affairs, right? So I don't know, my first word of advice would be, please do look at the past 2-3 years of DU-JAT papers, because it will give you an idea of what kind of questions come in the actual exam, right? Now, a general trend is that these questions focus on either specific corporate affairs. These could be about brands and tag names, or any new acquisitions that happened, or any new mergers that happened in the, in our Indian landscape of business. Or it could also have some current affairs questions around the Indian economy, right? So if you're preparing for the DU-JAT, then do keep searching online. I'm sure there are plenty of Telegram channels which do claim to be giving you current affairs. But make sure that most of these sources will be very, very vast. And so the idea is to try and narrow it down to specific questions that come on the DU-JAT. So take a look at the past papers and maybe fine tune whatever current affairs materials you're using. B, on our part, Aptitude is going to, we have plans to be to give you a lot of current affairs on the YouTube channel. So, our backend team is working furiously to sort of get some sessions ready in, the next month. So wait patiently, maybe for a week or so, and we will also start posting current affairs specifically for the DU-JAT, and that should also help you. No, that wasn't Indore, Anshuman. I'm talking about IIM Rohtak. IIM Rohtak has already announced that on the 20th, the exam has a MCQ part, and it also has a WAT, right? There's a half an hour WAT section that you will have to attempt. So that's what I'm talking about. So far, Indore, we don't have any update yet. The sense is that one way or the other, WAT will happen in the IIM Indore process as well. So do make sure that you attend tomorrow's session, and this might work out as good practice, right? In any case, I would urge all of you to be to continue to read newspapers and magazines to try and build up your knowledge on some key sort of topics in the current day and age. We have, a couple of months back, we did share a list of indicative topics. And so that should serve as a primer for your research. So make sure that you start researching on some of those areas. Yeah, I think that's a smart thing to do. All right. So let's get into today's session. We are discussing calculus. We've already shared two exercises for the day, one on differentiation and one on integration. These are broadly the kind of questions. Obviously, I will sort of give you a disclaimer that these are probably a few questions slightly one notch above the actual level in the exam. But let's try and sort of make best use of whatever practice we can. Right. So first up, differentiation. I'd like you guys to quickly open up the class exercise and start off with question number 1, which asks you for the interval in which the given function is differentiable, right? Could you quickly sort of spend a minute with this question and tell me what you think would be the answer? It's a very interesting question. Okay, already queries pouring in. Will we need to use the test of differentiability? Should I look at left-hand derivative, right-hand derivative? I hope that you remember these concepts from your class 12 syllabus. Yeah, that's okay. Already have an answer. Okay, glad that somebody figured out the unique feature of this problem. Right, Anshuman, congratulations. I was waiting to see how many of you are going to spot this, right? Option C and option D, if you look at them carefully, they are actually the same. Because if you look at option D, it has the interval, both intervals are closed at the endpoint 0, which means that 0 is included, which means that it will be from minus infinity to 0 and then all the way from 0 to infinity. So C and D are actually exactly the same. So this is one of those conundrum cases where even if I solve, will I really get a right answer? Right. So how do we do this? So this is a question which is unique because of the modulus in the expression, right? Fx is equal to x divided by 1 plus mod of x is the given function, and the question asks us to figure out where is this function differentiable, right? Now the thing about differentiability is obviously that you can use the concepts of left-hand derivative and right-hand derivative and try and use limits to figure it out. But an easier method, an easier approach to this problem is actually to say, okay, if this question, if I can somehow remove the modulus, how would that happen, right? So the function would split into two expressions depending on what happens to the modulus, right? And the modulus behaves like this. When x is positive, then the value of mod x is plus x, and x is negative, then the value of modulus of x is negative of x, right? So what I do know is that this function itself will be broken up into two expressions. What are those expressions? So when x is positive, since mod x is equal to x, the expression will be x upon 1 plus x. But when x is negative, since the value of mod x is negative of x, it will be equal to x upon 1 minus x, right? So those are two expressions I get, right? And so if I can get to this point, then I start to think, is this, yeah, given that this is an expression, given that this looks like a polynomial, where is this polynomial not defined? Where is this polynomial? Where will the polynomial not have a given value? Because if the function exists everywhere, anything that is expressed as a polynomial usually is differentiable everywhere. So is this function, does the function value exist everywhere? So immediately the moment you ask yourself that question, you'll figure out that when denominator is equal to 0, then the function will not exist. Yeah. So when is the denominator 0? Which means if I continue that thought, the denominator is 0 when x plus 1 is equal to 0, and in this case when 1 minus x equal to 0, right? So which means that the denominator and the function, hence denominator becomes 0 when x is equal to minus 1, and here when x is equal to 1, right? And since the denominator becomes 0, this would mean that x equal to minus 1 makes this function not differentiable, right? But then that also means x equal to minus 1 does not agree with our domain, right? Because we said this following expression for fx happens only when x is positive. But since I'm getting x equal to minus 1, this point will never be reached, which means other than this point, the function does have an expression in all places at all points. So the function is differentiable everywhere in x is greater than or equal to 0, right? Similarly, in the second case, when x is negative, the expression being this, the denominator becomes 0 when x is equal to 1. But then x equal to 1 is not a negative value of x. So this value of x will never occur in that domain, which means that the denominator will never become 0. So the function is differentiable everywhere as long as x is negative, right? So if the function is differentiable everywhere when x is negative and everywhere when x is positive, and also includes the point 0, then the answer should be it's differentiable everywhere. Yeah. So that's like a shortcut to work with expressions. Whenever you have a polynomial expression, if I give you an equation like fx equal to 2x plus 4x cube minus 5x, you'll say, okay, I don't need to do minus 5x square. I don't really need to do much with the left-hand derivative or the right-hand derivative here, because as long as it's an expression containing x, it will have a curve which is smooth everywhere, and there are no breaks in the curve, right? So the logic is wherever the curve has a break is when the function will not be differentiable. And where will the break happen? When the function is discontinuous. And where will a point of discontinuity happen? In this case, no point at all. But when it has a denominator, the discontinuity will happen when denominator is equal to 0, because at that point the curve will, denominator becomes 0. The curve is not, the value of function is not defined, and so the value actually approaches infinity or minus infinity, and it won't be differentiable there, right? But then that case never happens. So this function should be differentiable everywhere, and you probably can avoid using left hand or right hand derivatives here. Yeah. So I think the idea here was to expose you to questions that involve modulus, right? If this makes sense to you, try your hand at the next question. Question number 2. Find the derivative of the function y is equal to x mod x with respect to x. How do I differentiate something which has a modulus? Right. Again, let me give you a minute to sort of absorb the question and see how you can proceed. Oh, by the way, the confusion still stands, doesn't it, in the previous question? Since the value we're getting is it exists everywhere, ideally we can mark C and D both, right? Now, when that happens, the first thought in your head should be maybe I did something wrong. So make sure that you check your workings in the problem. But if everything seems right and you figure out that indeed the option choices are incorrect, it doesn't matter if you mark C or you mark D, you will be awarded marks for both answers. So for this question, option C or option D, both of them are correct. Ignore what, ignore if only one of them is given in the solution, ignore that. Okay, Hardik has a very quick answer. Let's see if you guys agree with him. Well, Anshuman, that doesn't work, man. You can't choose either C or D. Pick a choice. It either exists or it doesn't. You can't say it. If it exists, it's 1 by E. If it doesn't exist, then it doesn't. All right. Okay, let's see what happens here. Y is equal to x mod x, and I want to differentiate this. So do the same thing we did in the previous question when split it into two domains, right? X is either positive or 0. Second case when x is negative. If x is positive, mod of x equal to x, which means the value of the function y will be x into x. That's y is equal to x squared. So what will, if I treat this as f of x, then the first derivative f dash x, I can directly differentiate, right? It will become 2 times x. Okay, and what happens when x is negative? Then the modulus will return me the negative of x, which means the value of y will be x into minus of x, which is minus of x square. So y dash or f dash x will be equal to minus into differential of x square, which is 2x, right? So in one case I'm getting 2x, in one case I'm getting minus 2x. Obviously A and B, both of them, I'm getting both of these choices. So what do I do, right? But then if you look at the options, then it gives you a big hint. Option says 2 times mod of x. Okay, so why not replace this with the mod? In this region, in this part of the x-axis where x is positive, mod of x equal to x, which means I can write this as 2 times mod of x. Whereas in this domain, mod of x equal to negative of x. So negative of x can be written as mod of x. So in both cases, I'm getting 2 times the modulus value. So indeed, correct choice is option C, right? So when you're doing questions involving moduli, questions involving these function types like logs, please make sure that you'll take a look at the option choices. Sometimes it can actually present you with a very, very good hint. Yeah. Least incorrect or not, Siddhant? This is the right answer. Right. Okay. How about question number 3? About question number 3, we'll want to sort of pick up work at a good pace in the session today because we have a lot to cover, both differentiation and integration, which means that you guys need to be on your toes. If this is sine inverse 2x upon 1 plus x square, I think you guys should be able to figure it out fairly quick. Okay, there's a typo in this question. Again, I'm very surprised none of you pointed it out. The question seems to ask for dx by dy. Dx by dy should ideally be in terms of y. And so how is it that all options are in x, right? So it should be, please correct it, it should be dy by dx. And that's the only valid question in this case. So what do we have? I have y is equal to sine inverse of 2x upon 1 plus x square. And if you know your trigonometry, then there's a very easy substitution to start this question, because if you put x as tan theta, then 2x upon 1 plus x square inside the bracket will be 2 tan theta upon 1 plus tan square theta. And I know from trigonometry this is actually equal to what is 2 tan theta upon 1 plus tan square? That's equal to sin 2 theta. Yeah, so that's the first thing I know, right? So if I substitute that, then what will y become? Y will become sine inverse sine 2 theta. So that's like 2 theta, which means that will be 2 times, what is theta? Tan inverse of x. So by our substitution, we end up getting to 2 tan inverse x. So differentiate it now, dy by dx. I hope you remember what is the differential for tan inverse. That's 1 upon 1 plus x square. Absolutely. So this becomes 2 upon 1 plus x square, and look for that in the options. That's option B, 2 upon 1 plus x square. You guys are very, very diplomatic, man. You guys are actually editing. You are taking the trouble of editing comments on the feed, right? Which to me seems kind of futile. Chalega, let the comments stand. It doesn't matter. Nobody's gonna come and question you about those. Okay, let's try one with log. How about question number 4? Right? I hope this one was clear to everybody. Let's move on to question number 4. I know, Siddhant. I saw that. This should be an easy one. If you know your differentiation and you know your logarithms, then this is a very easy question. Okay, we have two quick answers. Actually, one quick answer and one medium answer. Medium paced answer, but what about the rest of you guys? Amazing. Most of you seem to have figured it out. As I said, it's a fairly straightforward question if you know your logarithms, because what is y given as? Log x square into log x, right? Even though it's written in brackets, you know that this is log into log. And whenever you have an exponent inside the radicand, the power comes out. So this becomes 2 log x into log x, which obviously reads to me as 2 log x the whole square. So if this is the value of y, then I'm going to use the chain rule when I differentiate dy by dx. Right? So first you will differentiate. It's the square of a function, so that becomes 2 into square ka differential hota hai 2 times differential of the function itself. So 2 times differential of d by dx of log x. And what is d by dx of log x? D by dx of log x is 1 by x. So what I end up getting is dy by dx is equal to 4 by x, which means f dash x at e will be equal to, put the value of x as e, that directly gives me the answer as 4 upon e. That's, I think, option D. Yeah, it's a fairly straightforward question. Yeah, let's try one more from logs. Try question number 8. Try question number 8. Another problem involving logarithms. Okay, nice. I have one quick answer. ये टॉपिक आईपी मैट IIM रोहतक में शायद नहीं है, but it's definitely a topic which comes on IIM Indore. DU-JAT IIM Indore में definitely आता है differentiation. So I don't know what to say, Mr. Shen. Relevant नहीं है तो आप यहाँ कर क्या रहे हो, है ना? नहीं, it is relevant, my friend. In fact, that's one of the reasons why they say that it's a tough exam to crack. Okay, I have a couple of answers saying D. Okay, Kriti has already changed her choice. She retracted her answer. How do we do this one? And so it's a question where you need to use property of logarithms as well as property of calculus, properties of differentiation. Yeah. So let's look at this one. I'm given the function fx as log in the base of x square, and the radicand here is log of x. Remember, यहाँ पे it's saying log of x in the base a होता है usually, ये base होता है, ये radicand होता है. In this case, the radicand itself is a logarithm and the base is an exponent, right? So clearly, to proceed, the first thing I'll do is something that most of you are suggesting, which is change of base. Ideally, I don't want the base to be x square. I would like the base to be x. So change the base to x. So when you change a base, what's the property? The property of change of base is when you have log of x in the base a, you can change the base to b by simply saying log of the same radicand divided by log of the old base in the new base. For example, अगर मुझे क्वेश्चन दिया हुआ है log of 16 in the base 8, right? तो log का usually definition क्या होता है? What power of 8 makes 16, है ना? जैसे log of 16 in the base 2 अगर होता तो आप बोलते 2 का कौन सा पावर है जो 16 बना रहा है? 4th power, right? That would be easy to calculate. But here, if I think of powers of 8, 8 power 1 is 8, 8 power 2 is 64. तो ये 16 कहाँ से आया? तो इसको कैलकुलेट करने का सिंपल तरीका होता है चेंज ऑफ बेस, राइट? यू कैन से दिस एज log 16 by log 8, और आप कोई भी बेस चूज कर सकते हो आप, राइट? तो बेस कौन सा चूज करें? दोनों 2 के पावर्स दिख रहे हैं तो दोनों को 2 के बेस में रख देते हैं. सो 2 का कौन सा पावर है जो 16 बनाता है? 4th पावर. 2 का कौन सा पावर है जो 8 बनाता है? 3rd पावर. सो देयर यू गो. द वैल्यू ऑफ दिस लॉगरिथम बिकम्स 4/3, राइट? सो इफ आई नो दिस, here I will choose a base b as x because the base itself is a power of x. So f of x will then become log of log x in the base x divided by log of x square, which obviously when you have an exponent the power comes out. So this becomes log of log x divided by log of, in fact don't choose the base as x. Sorry. Choose the base as e, right? Why choose the base as x? Choose the base as e. So then this becomes log of log x divided by log of x square. I'm not writing the base. We can obviously write e over here. And so this becomes log of log x divided by log of 2 log of x, right? Why have x in the base? Remove x from the base because it's easy to then differentiate, right? And when you have logarithms base e, then the differential is actually 1 upon log. So now I can differentiate this. So when I'm differentiating, now the second funda comes, right? If you have a differentiation which is in the form f of x equal to a by b, when you're trying to differentiate a function which itself has a function a in the numerator and a function b in the denominator, then what do? You square b, right? When you're differentiating it, you square the denominator, and then you do b into a dash minus a into b dash, right? Absolutely, this is the quotient rule, right? So here in this case, I'm going to use the quotient rule. So here, first thing I'll do is that I'll square the denominator, right? So 1/2 को तो अलग ही रख लेते हैं, right? When I'm differentiating this, I'll remove the 2 from the denominator. So first square the denominator, so log of x the whole square, right? And then repeat the value of the denominator and then differentiate the numerator. Now, when you're differentiating the numerator, note that this is log of a function. So the first thing I'll do is 1 upon the function log of x into differentiation of that function. Log x ka differential hota 1 by x, right? Minus a into b dash. So minus the numerator itself, log of log x, into differential of the denominator. What is the differentiation of the denominator? That's going to be 1 by x. So this is the differentiation that I get. Now instead of trying to simplify this, you read the question and it asks you for the value of the differential, first derivative at E. So you want f dash x at E. So if f dash x is this, then what will f dash of, in fact, let me do it here, f dash of E be, right? So simply substitute x with E. So denominator becomes log of E. So what power of E makes E? The first power. So the denominator becomes 1 the whole square, obviously remains 1. And so I'm left with the numerator, obviously half comes here. So log of x is E, sorry, log of x is now equal to 1. So 1 into 1 by 1 is 1 into 1 by E. So I'm left with 1 by E minus log of log x. Log x is 1. So this becomes log 1 into 1 by E. What power of E? What power of E makes 1? E raised to the power 0 is 1. So this becomes half of 1 by E minus 0 into 1 by E, which clearly is 0. So answer is 1 upon 2E. Right? The correct answer, I'm sorry, I think some of the things I wrote in the denominator is not really clear. So this becomes 1 by 2 into 1 by E. So that's 1 by 2E. Yeah. And is that there in the choices? That's there in... Yeah, indeed, that's option D. 2E raised to the power minus 1 will be the inverse of 2E. So that's 1 by 2E. Good. So congrats. A lot of you did mark this choice. In fact, 2 of you did. And so good, if you are able to figure out the change of base followed by the quotient rule, will give you the answer to this particular question. Right? Okay, let's try something different. Let's try question number 9. Look at question number 9. I have fx, I have gx, I have hx, and a function which is a composition of all three functions, h of f of g. And the question asks me to calculate the double differential at that. Wow, this is going to be fun. Good going. At least in terms of pace, good going. Anshuman. Very nice, rest of you guys. Very good. Good. So a question which seems complicated isn't actually so complicated. Clearly not, because a lot of you are getting this, right? What does the question say? Question says, I'm given fx as equal to sine of x, and then I'm given g of x as x square and h of x as log of x, right? And the question says, if capital Fx is defined as h of f of gx, right? So the way you evaluate composite functions is inside out, right? So the first thing you will do is substitute gx from there. So this becomes h of f of, correct, f of g. What is g? G of x square is x square. So f of x square. Okay. Next thing is calculate f of x square. So h of that. What is h of x square? So which means this will be log of, f of x square. So this will be sine of, if it is f of x, it's sine of x. So f of x square will be sine of x square. Right? The idea is कि जो भी input है उसको x की तरह substitute कर दो, right? So you substitute x with x square and this becomes sin x square, and now I have h of this. H of x is log of x, so h of something else will be log of that. So this becomes log of sin x square. If this is fx, let's calculate the differential. F dash, first differential. For a logarithm, first I'll do inverse, so 1 by sin x square into differential of that function. Sin x square का differential है, sin का differential होता है cos, so cos x square into differential of the function contained within sin, at x square. So differential of x square is 2x, which means this actually becomes 2x into cot x square. This is f dash x. Next step, differentiate this again by using the chain rule. Break it up into, if it is a into b, it will be a into b dash plus b into a dash, right? So I can take the 2 common, right? If I take 2 as common and I differentiate this, what do I get? Right? So first, x into differential of cot x square. What is the differential of cot? Negative of cosecant square. So cosec square x square into differential of x square, that's 2x, right? Plus second function cot x square into differential of x, which is 1, right? So this is what I get, right? What is this? 2 into x into 2x is 4x square. So minus 4x square into cosec square x square plus 2 cot of x square. Yeah. And just look for the correct choice here. 2 cot x square minus 4 cosecant square x square is given in the choice. That's option B. Yeah. Again, a simple one. I'm not sure what happened, Rishita, but you retracted your comment. I hope it's clear. It's not a very difficult question. I think the fundamental block here was, can I calculate a composite function, right, at first and then differentiate it, right? So if I'm differentiating, I'll do it in steps. Okay, try your hand at the next one, question number 10th. A function y is given to us, then we need to find the product of 2 second differentials. Yeah, okay, Rishita, got it. Silly mistake. Please avoid silly mistakes at all costs. One of our previous questions had a typo. It had dx by dy, but then that can actually come in the exam, right? And this is an illustration of that exact concept. If I'm given an expression for f of x, y is equal to f of x, then how do I calculate dx by dy? Yep, Siddharth, that's right. The idea is when you want to differentiate x with respect to y is first to determine an expression of x in terms of y, right? Which is like the inverse, right? So first thing you want to do is to calculate dx by dy. You want to find the inverse of the function. Instead of y is equal to f of x, you want to write x equal to f of y. So first calculate that. And obviously given this expression of f of x, calculating the inverse will involve taking a log on both sides. For all the hints that you're giving, give me an answer. Siddhant has already given us a big hint. Okay, good. We have an answer. Okay, a couple of answers pouring in now. Right, let's discuss this. Question number 10 says y is equal to e to the power 2x. So the first thing is that to calculate dy by dx, I'm going to use the same expression. So I'll say dy by dx, let's just differentiate. When you have an exponent in the base e, then the differential is directly differentiate the numerator. Dy dx of e power x is nothing but e power x, right? So the first thing is differential of this will be e power 2x into differential of its power, right? Because here if you differentiate x, you get 1. But here if you differentiate 2x, you'll get 2, right? So this becomes dy by dx becomes 2 into e power 2x. And so d square y, if you differentiate this with respect to x, then you're trying to differentiate 2e to the power 2x. Yeah. Again, 2 is a constant, I can take that out. Differential of e power 2x, we've already calculated. That's 2 into e power 2x. So that becomes 4 into e power 2x. This is the second differential of dy of y with respect to x. Okay. Moving on to the second part where I want to calculate d square x by dy square. I'll first have to inverse this function, right? So y is equal to e power 2x. To calculate x in terms of y, you take log. Take log in the base of e. Right? So if you do that, the LHS becomes log y in the base e. RHS becomes, if you're differentiating e power 2x, that will be, if you're taking log of an exponent, log of e power 2x will actually be 2x into log of e. And what power of e makes e? The first power. So this becomes 2x. So log y is equal to x, which means x will be equal to half of log y. There you go. Now I've inverted the function. I've calculated x in terms of y. Now let's differentiate. So if I differentiate x with respect to y, first differential with respect to y. Yeah? So differential of log y will be 1 by y. No problem. What about the second differential? Right? Differential of 1 by y will be minus 1 by y square, right? And at this point, I'm going to substitute the value of y. So this becomes 1 by 2 into minus 1 divided by square of y will be e power 2x the whole square, right? And so that will be half of minus 1 divided by, when you have an exponent raised to another power, the powers get multiplied. So this becomes e power 2x into 2, that's 4x, right? And the question asked me to multiply these. So d square y by dx square into d square x by dy square will actually be 4 into e power 2x into half into minus 1 by e power 4x. So cancel this off. This becomes 2 as the constant. And since both of these have, and there is a negative sign, and since both of these are in the base, same base e, you can subtract their powers. 2x minus 4x becomes 2 e power minus 2x, right? So the product is indeed option D, 2 into e raised to the power minus 2x. Hope that makes sense, right? So this question I give us something more to sort of remember, right? Whenever the question asks me for differential of x with respect to y, you can inverse it. You first need to inverse it and then proceed with the differential. Okay. Okay. Some very unique problem types to follow. Look at question number 11. That's a very, very atypical question. It's a very atypical question, question number 11th. You can choose to do anywhere, Siddhant. It doesn't matter. X and Y are both input variables. There are two variables x and y and both are inputs to the function f. Both are possible inputs to the function f. ये क्वेश्चन एग्जाम में करना चाहिए? Should we be attempting this kind of question in the test? Question is wrong. You wish. Oh, Arushi is getting there, man. Wow, we have an answer. None of these. It's not really an answer. Come on, Siddharth. Even you have support, man. Anshuman agrees with you. आप कह रहे हो गलत है, Anshuman also says it's wrong. है ना, तो जो नहीं आएगा उसको wrong बोल देंगे, या छोड़ दो. I think I'll stand with you if you guys say, sir, ये question exam में we will not attempt this question because this is very different, right? And इतना टाइम नहीं है वेस्ट करने के लिए, right? कि इस क्वेश्चन पे रिसर्च करें, right? So that would be something I am inclined to agree with, right? But let me show you, right, how it can be solved and also how you can actually understand from the problem about the likelihood of solving this question, right? So for example, here the other x, f of x plus y is, a function where you can multiply then fx into fy. If you have f of something plus something, then you can multiply their individual function values, right? Okay. This is true for all values of x and y, positive, negative, and whatnot. Now the question gives you, right, the value of f of 5 as 2, and it, curiously enough, it gives me the value of f dash at 0. So it gives me the first differential at 0 as 3, and it asks me for the first differential at x equal to or 5. Right? So it asks me for the differential at 5. So if I'm given the first derivative of 0, how do I calculate the first derivative of 5, given that I have values of function? So if I don't have an expression for fx or fy or fx plus y, then how do we proceed with a question like this, right? Now, again, there should be a eureka moment here, right? If you don't have an expression, how do you calculate the differential? Something comes to mind? If I don't have an expression for f, then how do you calculate the derivative? How do you define derivative in terms of limits? How do you calculate the derivative of a function using limits? If you remember this, you would have definitely studied this at school. F dash of x at x equal to a is defined as f dash x equal to limit h tends to 0 f of a plus h minus f of a divided by h. You remember this? And the moment you remember this, eureka moment will also happen. Array, this one has f of a plus h, so I can use that property also, right? So if I remember this, eureka moment has happened, right? So since I want the derivative at 5, I'll start with f dash at 5. But since I'm given the derivative of 0, I'll also write an derivative for f dash at 0. I'll try and use both, right? What is derivative at 0? Limit h tends to 0 f of 0 plus h minus f0 divided by h. This is f dash of 0, right? If I work with this a little more, this will become limit h tends to 0 and f dash of 0 is given to me as 3. So limit of f h, in this case, I don't need to really split it. 0 plus h is h. So fh minus f0, what is f0? I don't know f0. Okay. Divided by h. Right? Now, and what is f dash at 5? Okay. This will be limit h tends to 0 f of a plus h. So that's 5 plus h minus f of a, that's f of 5 divided by h. And in here, I can then use property and use the value of f of 5, right? So this becomes limit h tends to 0 f of 5 into f of h minus f of 5 divided by h. So f of 5 in the numerator is common and the value of f of 5 is 2. So I can actually bring that out. So this becomes 2 times limit h tends to 0 f of h minus 1 divided by h. And if you now compare this expression with the given expression for f dash at 0, the only thing missing is if I can somehow prove f of 0 as 1, right? Now that's where there's a little more work to be done, right? So again, use this expression and think of what will f of 0 plus 5 be. This will be f equal to f of 5. And I know the value of f of 5 is 2. But f of 0 plus 5 will itself be f of 0 into f of 5. And since f5 is not 0, I can cancel it out. So which means what is the value of f of 0? Equal to 1, which means this is 1. So 3 is actually the limit of h tends to 0 using this fh minus 1 divided by h. And that's exactly what I wanted. So I can then substitute this as 2 into 3. Answer is 6. So the required derivative f dash at 5 is actually equal to 6. Will this, will these steps, one step, second step, derivative using limits, and marrying this there, these three things should occur to you. Is it possible for that to happen in the actual IPM exam? Absolutely not. Right? I don't really expect you to be solving a question like this if it comes in IPM. Right? But like everything else, now that you've done a tough question using derivative, where we calculated derivative using limits, it's definitely something you can try for a minute, right? Don't outright leave a question like this. Maybe spend half a minute, see if it gets you somewhere, right? And if it doesn't, maybe skipping this question was actually a good choice, right? Okay, any questions, any doubts? 3 steps here. First, use derivative, calculate derivative using limits, and make an expression for f dash 0 and f dash 5, and see how we can use f dash 0 to calculate f dash 5, right? And step number 2 is calculate the value of f of 0, right? By the moment I get an expression like this, the easiest thing to do is put x as 0. So f0 plus y, fy is equal to f0 into fy. So fy will probably get cancelled out. It's a substitution which you must definitely try. I think it's one of the most common sort of substitutions, right? So both of these independently are not that hard, but figuring out all of this in the exam might not be the easiest thing to do, right? So is this clear to everybody? Can't we use product rule? You can if you did know no, you can't differentiate constants, Anshuman, that's the problem. You can't say f dash of 5 will be f dash of 5 plus 0, so it will be f dash 0 into f dash 5. That doesn't make sense, right? I think what you're trying to ask me is something like this, right? We want f dash of 5. So can we write this as f dash of 0 plus 5 and then write this as f dash 0 into f dash 5? Right? And the short answer is no. The product rule can be used when you have an expression. So all your properties of derivatives can be used only if only if the question gave you an expression for fx. But this question doesn't give me an expression. So how do you use the product rule at all? Right? In fact, this property when applied is actually not a property on general expression. It's a property on specific values that we've substituted. So we can use derivatives only in that case. A very creative comment from Siddhant. Where? What do you mean where? Oh, he's asking Anshuman, is it? Can't we use product rule? Where? Oh, okay. Yeah. All right. So I think I'm actually going to ask you to try the remaining questions yourself. Maybe discuss a question or two which is of a different variety, but then most of the questions then are very, very, if they're different, then are also very, very hard, right? Okay, let's try something different. Question 14. And question number 14th and 14, 15. Yes, and 17. 14, 15, and 17. I want you to try all 3 questions. They are a little similar because these are applications of derivatives, right? 14th isn't, but 15th and 17th are. So try question 14 15 and 17. 14th is the normal property of derivatives, but in the parametric form. And 15th and 17th are actually application of derivatives, right? See if you can figure it out. 15th is quite straightforward, actually. Yeah, I'm going to give you 5 minutes. Guys, try this. Try get this done, and we can then jump over to integration, the second sort of point of discussion for today. Okay. Most of you seem to have made headway with all three. Sure. Okay. Okay, let's talk about these. Yeah. Question number 14th first. I don't seem to see too many guys having scored 14th. Most of you have done 15th and 17th, but have skipped 14th. Okay, Arushi says A, Anshuman says B, Siddhant says how. Let's figure this out, right? So what is given, right? Let's look at a given expression for the function. So y is equal to f of x is defined parametrically, right? So both x and y are defined in terms of t. So x is defined as 2t minus mod t and y is defined as t square plus t into mod t. Yeah. So obviously what I'll do is both x and y, I'll split into the range t, I'll remove the modulus first. So when t is positive and when t is negative, and try and calculate what happens with x and what happens with y. So when t is positive, mod of t will be t. So x will become 2t minus t, which means x becomes t. And when t is negative, mod of t will be minus t. So x will become 2t minus of t. That's like 3t. Okay. Which means when t is positive, t is equal to x. When t is negative, t is equal to x by 3. Right? So I can calculate t, the value of t in terms of x. Let's move over to the other side. Right? What happens when t is positive? So when t is positive, mod of t is equal to plus t. So y becomes t square plus t into t, which is 2t square. Yep. And the value of, when t is negative, the value of y will be t square plus t into, since t is negative, mod of t will be minus t. So this becomes 0. Right? And remember, we wanted to calculate the derivative of y with respect to x. So what you're focusing on is y. So if you look at this, when t is positive, x is equal to t. And so let's think about it this way. What happens when t is positive? X is equal to t and y is equal to 2t square. So I can combine these two and eliminate t, which means y becomes 2 into x square. What happens when t is negative? X would be equal to t by 3, but then it doesn't matter because y then is equal to 0. And where is t negative? T will be negative when x is also negative, because x will be t by 3. So if t is negative, x will also be negative. So what I can, and when t is positive, x is equal to t, so x is positive in that case. So basically you'll end up getting y is equal to 2x square when x is greater than or equal to 0, and y is equal to 0 when x is negative, right? So this is something that I can figure out. And the moment I have this, I can simply differentiate. At this point, I can simply differentiate. So what happens? Y dash of x should be equal to 4x when x is positive or 0. Since the function itself is 0, the derivative will also be equal to 0. So the answer to question number 14, I'm getting 4x. And the question asks me for the value of the derivative when x is positive. So clearly when x is positive, derivative is 4x. Answer is option B. So question 14th, answer is option B. I hope that makes sense to you. Right? The idea is to eliminate the parameter t between x and the expressions for x and y. But given that there is a modulus, you'll first have to split it into ranges for t and t being positive, t being negative, and then combine it. Right? That's what we did here. I hope that makes sense to you. Okay, moving on. Next up is question number 15 that says a spherical balloon is expanding such that its radius increases at the rate of 5 inches per minute. radius increases at 5 inches per minute, which means dr by dt is 5. Right? And the question says, then the rate at which the volume increases at a point where the radius is 10 will be what? So you want dV by dt, but what is V? What is the volume of a spherical balloon? Volume is 4 by 3 pi r cube. So if I want to differentiate this with respect to B, dV by dt will be equal to, so obviously 4 by 3 pi. Differential of this with respect to t will be 3r square into dr by dt. So 3 and 3 gets knocked off. This becomes 4 into pi r square into dr by dt. You want the value of this function when r is equal to 10. Right? And given that the rate of change of the radius is constant, 5. So then I can substitute both values. This becomes 4 pi into 10 square into 5. So 4 into 5 is 20. 20 into 100 is 2000 pi. That's option C. Yeah. So 15th, I thought was a very simple question. Answer is option C. The balloon's volume will increase at a rate of 2000 pi cubic inches per minute. Okay, let's move on to 17th. The question asks for a maxima value. Right? A quick recap about maxima. To calculate maxima, right? The first thing you'll do is for max or min, you calculate f dash of x is equal to 0. Put the first derivative equal to 0 and solve it, right? So if let's say this happens at x equal to a, right? Then for x equal to a to be a maxima, for x equal to a to be a point of maxima, the second derivative of x at x equal to a must be negative. Whereas for x equal to a to be a minima, the second derivative must be positive. Obviously at x equal to a. Right? So this is the principle I'll use. Right? Differentiate, calculate the critical points, and then calculate the second differential at exactly those critical points. And wherever the second differential is negative is the point we will report as the maxima. Right? So I'm going to try and do this. Given function is f of x equal to x to the power 1 by x. Right? So clearly, to be able to differentiate this, first thing I'll do is take log. So log of fx will be equal to log of x to the power 1 by x, which is, take the power outside, 1 by x into log of x. Right? And now differentiating on both sides with respect to x. Differential of a log will be 1 by the function into differential of that function. And differentiate this by using the quotient rule, right? So log x upon x, square the denominator, x into differential of log x will be 1 by x, minus log of x into differential of x will be 1. So what do I get? I get 1 minus log x upon x square. And obviously, since I wanted the first derivative, this will actually be equal to f of x into this expression. Right? Now, you put this equal to 0. You want the critical point. So put the first derivative equal to 0. Where will it 0? Either when fx itself is 0, right? Can x to the power 1 by x ever be 0? No, an exponent can never be equal to 0. An exponent is always positive, right? An exponent, when the base is positive, remains positive. When the base is negative, depends on the power. In fact, it will probably be discontinuous when the base is negative, right? So forget that. So fx can't be 0, which means the other expression must be 0. So 1 minus log x must be equal to 0, which means log x must be equal to 1, which means x must be. So remember, this is the base e. So taking an antilog, I'll get x as equal to e to the power 1, which is e itself, right? So the critical point I get is x equal to e. Now my suspicion is that this should be the point of maxima. If I check the option choices, since there is only one critical point, Is e to the power 1 by e there in the option choices? Yes, it is. Option B gives me e to the power 1 by e. So at this point, actually, I should be comfortable marking option B. It must be the correct choice, right? But if you want to be sure, then let's check the second derivative also. To calculate second derivative of x, you will differentiate this expression, f dash x. I have an expression for f dash x. Let's calculate its derivative with respect to x. So using the chain rule, fx into something else, differential will be first differentiate this and leave the other thing unchanged. I probably need a little more space. So I'm going to go a little more to the left. Double dash x will be, let the bracket be as it is. So 1 minus log x upon x square into f dash x plus, leave fx untouched and differentiate this. Obviously using the quotient rule, x power 4 into x square. Numerator will be x square into differential of this. Differential of 1 is 0 minus differential of log x, which will be 1 by x. Right? I mean, maybe write it below, plus fx into x power 4, x square into minus 1 by x, minus 1 minus log x into differential of x square, which will actually be 2x. Right? And we want the second derivative at x equal to e. So if I put x equal to e, the first expression f dash e is equal to 0. F dash at e we know is equal to 0. I know that is the critical point. So the first expression automatically becomes 0. Second expression becomes f of e into, this is minus x, so minus e, minus 1 minus log e. Log e is 1, so 1 minus 1 becomes 0. 0 into 2e will obviously be 0 divided by e to the power 4. Right? So what I get is fe into minus 1 by e cube. F of e is positive. E is also positive, which means this second derivative, since it has a negative sign attached, f double dash at x equal to e is actually negative. So it indeed proves my point, which is that x equal to e is a point of maxima. I'm not sure I understand your question, Siddhant. What do you mean substitute x equal to 2.7 in the option choices? What does that really achieve? Doesn't make sense. E is anyway something that you know. How do you, by substituting, how do you know which of the 4 choices? It might, one of those values might actually not even be generated by the given function, right? So how do you know that? Like for example, option A, 1 by e to the power e will be at x equal to 1 by e, okay? Option B is at x equal to e. But how about option C and option D? They won't ever get generated, right? X power 1 by x equal to e happens at what value? I'm not sure. No, you can't do that. Correct answer is indeed option B, right? X equal to e is the minima, right? So the question asks you find the x equal to e is the maxima. The question asks you find the maximum value. So max value will be f of e. So substitute x equal to e here. This becomes e to the power 1 by e. So answer is option B. Raghav, I think Raghav is asking me the question. So indeed, Raghav, answer is option B, which is there, which is anyway given in the answer key, option B. Right? Okay. Let's switch over to, I would implore you to try the remaining questions yourself. I've left out a few, but I've hopefully discussed the most important ones from the given exercise set. So let's move over to integration now. Is everybody ready? Let's move over, open the second exercise for today, integration. We'll try and look at a few questions from here very, very quickly. And let's start with the first one. I think a very basic question. Integral of dx by, it's an indefinite integral, x power 4 plus 5x square plus 4 in the denominator. I know I can factorize the denominator, but what do I do after that? No. One more approach which you guys are missing out. Also something you've learned in CBSE in class 12, sorry. Right, remember, after you split it, what do you do? Replace with tan x. No. Remember what I have. What I have is, you want the value of integral of dx upon x power 4 plus 5x square plus 4, right? Even if you complete the square, you'll end up getting an integral of x square plus something else. X square plus something, the whole square plus or minus something else, right? Do you have a direct formula for that? I think not. Yes, that's right, Siddhant. Absolutely. Right? You can very easily spot, it's easy to factorize this, right? I'm going to leave it for you to try yourself, but the factors will be x square plus 4 into x square plus 1, right? Now, the moment I reach this point, I should think, do I have a formula for integral of dx upon x square plus a square? Do I have a formula for this? If you guys know the formula, please confirm. Do I have a formula for integral of dx by x square plus a square? No answers? Yes, absolutely. Yes, this is equal to 1 by a into tan inverse x by a. Yes, Arushi, yeah, right. That's right. So what I should do is, somehow if I can split this into two expressions as x square plus 2 square and x square plus 1 square, I would be able to get the answer. So the trick here is to split this into two parts, right? So how do you split this into two parts? Partial fractions. You can think, right? You can do this separately also. 1 by x square plus 4 into x square plus 1 can be written as a by x square plus 4 plus b by x square plus 1. And you can try and calculate the value of a and b. Yeah. See if you can figure it out. Let me give you a minute to try this. What is a and what is b? You remember this? Should look familiar. Must have done this at school. Taking an LCM, x square plus 4 into x square plus 1, and this becomes ax square plus bx square. So a plus b into x square plus a plus 4b. And if you compare it to the right and left hand side, clearly the coefficient of x square is 0, which means a plus b must be 0. and the coefficient of, and the constant is 1, which means a plus 4b must be 1. And from here, I'll say a should be the negative of b and take that and substitute here. You'll get minus b plus 4b is equal to 1, means that b will be equal to 1 by 3. And so a would be equal to minus 1 by 3. So what does this split as? This will be split as a, which is negative 1 by 3, minus 1 by 3 integral of dx by x square plus 4 plus 1 by 3 into integral of dx upon x square plus 1, and then tan inverse. So this will be x square plus 2 square. So 1 by a, 1 by 2, tan inverse x by 2 plus 1 by 3. Here a is 1. So 1 by a will be 1. Tan inverse x by 1. So tan inverse x. Is that there in the option choices? 1/3 of tan inverse x minus 1/6 of tan inverse x by 2. Is that there in the option choices? Take a quick look. Indeed, that's option D. So partial fractions yaad rakhenge. Whenever you have x square plus a square, multiple terms containing x square plus a square, must remember partial fractions. Right? This sounds more like a quick recap of what you already know. And it's supposed to be that way, right? All of these concepts have already been covered by you in school. You should remember it from a couple of months back. Maybe you're a little rusty, but most questions here will be essentially applications of right. I'm not sure if you guys need to revise that. Please go ahead and do that. But some of the basic concepts like the expression for indefinite integrals, x square plus a square, x square minus a square, 1 by root of a square minus x square, 1 by root of x square plus a square, 1 by root of a square minus x square. All of those, integral values you should know. You must also know integral of fx into dx. I hope you remember that. Integral of uv. Integral of u dv. All right. Let's move over to the next question. Which one should I pick? Okay, try question number 4. Question number 4, Arushi. Try the 4th question, guys. Very nice. Fourth one asks me to calculate the integral of dx by x root 1 minus x cube, right? Now, I don't have a direct formula for this. I don't really have a direct formula for this. So, I'm going to use the method of substitution here, right? So, clearly, I need to make a smart substitution here. Since it's a cube, then a trigonometric substitution doesn't make sense. I'll directly put a polynomial substitution. Let's say 1 minus x cube is a square, so that the square root goes away. So, if 1 minus x cube is t square, then differentiating it with respect to x. Here I'll get minus 3x square dx will be equal to 2t into dt, right? So I can't directly substitute dx. I need x square along with it. So I'm going to rewrite the integral itself as, since I need 3x square, I'll multiply by minus 3x square and also divide by minus 3x square, right, into root of 1 minus x cube, right? And then I can substitute, right? If I substitute this as t, this becomes root of t square, right? This becomes minus 3x cube. So I'll take the 3 outside, minus 1 by 3 outside. This becomes x cube. And what is x cube? X cube will be equal to 1 minus t square. Okay. Numerator is minus 3 square, 3x square dx, that will be equal to 2t dt. So what do I get? Minus 2 by 3 common, right? This t and root t square will cancel out. I'll end up getting integral of dt by 1 minus t square, right? Now what's the formula for integral of dx upon a square minus x square? Integral of dx upon a square minus x square is 1 by 2a into log of x mod x minus a by x plus a plus c, right? So clearly, in this case, I can make that substitution. So this becomes, sorry for that, this becomes minus 2 by 3 into 1 by 2a. In this case, a is 1. So 1 by 2 into log of x minus a upon x plus a. So this will be t minus 1 by t plus 1. And I can then, sorry, x plus a upon x minus a, right? Sorry. Since this is a square minus x square, it will be x plus a divided by x minus a. So this becomes t plus 1 divided by t minus 1. Is that there in the option choices? Obviously, t will have to be substituted by root of 1 minus x cube. So 1 minus x cube. So you can see that option B doesn't have the negative sign. If you take the negative inside, it will go into the power, which means the inverse of this, right? So it will become denominator root of 1 minus x cube, minus 1 will come in the numerator, and root of 1 minus x cube plus 1 will come in the denominator, and 1/3 of that is indeed outside the logarithm, right? So the correct answer is indeed option B. Yeah, hope that makes sense. Okay, look at something else. How about the fifth one? How about question number 5? Okay, let me explain this again, Raghav. So what we started with was, the rest of you can start question number 5. Square root of 1 minus x cube, देखते ही आप कहोगे इसको हटाना है, right? So I can substitute 1 minus x cube as t square. So t square under the root will become t, right? But to do that, I'll also have to substitute minus 3x square as 2t dt, right? So I want somewhere, I can't directly substitute dx. I'll need to make minus 3x square. So I multiply this equation with minus 3x square and divide it by minus 3x square. Numerator directly 2t dt बन गया. Now this becomes minus 3 into x cube. So minus 1 by 3 बाहर ले आए. X cube calculate करेंगे. This, if you rewrite this, x cube will actually be equal to 1 minus t square. So then I wrote x cube की जगह I wrote 1 minus t square, and root of 1 minus x cube will become root of t square, right? So this is t and t will get cancelled out. You'll end up getting minus 2 upon 3 into dt by 1 minus t square. After that, it's a direct formula. You need to know the expression, right? You need to know Integral. What is the value of integral of dx by a square minus x square? It's 1 by 2a log 1 plus x upon 1 minus x. Sorry, x plus 1 upon x minus 1. Sorry, x plus a upon x minus a. So directly substitute that here. Here a square minus x square. A is 1. So if a is 1, 1 by 2a will become 1 by 2 into log of t plus 1 by t minus 1. But t is root of 1 minus x cube. So if you substitute, you will end up getting minus 1 by 3 into log of root 1 minus x cube plus 1 divided by root 1 minus x cube minus 1. But since there is a negative sign, you can take this inside, right? This will become 1 by 3 into log of this raised to the power minus 1. And what is something raised to the power minus 1? Inverse, which means ulta ho jayega answer mein. So look for a choice where 1 minus root of 1 minus x cube minus 1 is there in the numerator. That is there in option B. So that's the correct choice. Hope that makes sense now? Yeah, great. By the way, guys, I think there is some confusion in question number 5. 1 plus sin x is not there in the power. It is e power x into 1 plus sin x. This is the question. Integral of e power x into 1 plus sin x divided by 1 plus cos x. This one is by parts. Sorry, Kalpana. Okay, Kalpana wants me to explain this question again. मैंने question मिटा दिया है, but question number 4 had the expression as integral of dx divided by x root 1 minus x cube, right? So the idea was that I can't make a trigonometric substitution, so I want to remove the square root, right? So you want this expression to be t square. So that's the first substitution I did. 1 minus x cube equal to t square means x cube will be equal to, take this on the other side and bring this here. So x cube will be equal to 1 minus t square. Okay, that's the substitution I'm making. But usually when you're making a substitution, you also differentiate, right? So you differentiate on both sides with respect to x. So 1 ka differential 0 ho gaya, negative. What is the differential of x cube? 3 into x square into dx, right? And on the right hand side, integral of differential of 2 t square will be 2t dt. So this is a substitution I want to make. But to make this substitution, I need x square along with dx, but I only have dx in the numerator. So to get minus 3x square, you multiply with minus 3x square and you also divide with minus 3x square. So I rewrite that integral in this form, right? Now numerator as it is will become 2t dt. Denominator, this part 1 minus x cube can be substituted with t square. And then I'm left with minus 3 into x cube. So x cube can be written as 1 minus 3 square. So this becomes minus 3, that I bring that outside. So this becomes minus 1 by 3. Numerator has already been substituted. This root t square has also been substituted. I'm left with only x cube. So x cube is 1 minus t square. So that's the value I put here, right? And t and root of t square. Root of t square is t, so I can knock knock it off in the numerator and the denominator. T cut jayega. 2 bahar le aao, so minus 2 by 3 dt by 1 minus t square. Fir ye formula apply karo, right? You have dx by a square minus x square. This is in terms of x, this is in terms of t, but the formula is still applicable, right? When you have dx by a square minus x square, it will be 1 by 2a into log x plus a upon x minus a. Here you have integral of, this is minus 2 by 3 into integral of dt by 1 square minus t square. Can you see this? Same form. So a square minus x square will be 1 by 2a. What is a? 1. So 1 by 2 into 1 log of x plus a. So this will be t plus 1 divided by t minus 1 inside the modulus. Right? Now ye 2 or 2 cancel out ho jayenge. So I'll be left with minus 1 by 3 into log of, now substitute t as root of 1 minus x cube. Right? And when you have negative, remember the logic here is log of a power n is n log a. ये log की property है. Log of a power n is n log a, which means if you have something outside, you can take it inside the logarithm by putting it into its power. So you have minus sign here. If you take that inside, it will become a value inside raised to the power minus 1. And when you raise something to the negative power, it becomes inverse. Correct? What is a power minus 1? 1 by a. So इस expression का inverse हो जाएगा. Right? And look for that in the option choices. That's option B. Right? I hope that makes sense to you, Kalpana. If it doesn't, please go and watch this again. Try it yourself very slowly. It will make sense. Right? Okay. Next one is integral of e power x into 1 plus cos x, 1 plus sine x divided by 1 plus cos x, right? And you see 1 plus cos x dikhta hai, there is a easy expression which must come to your mind. Okay, both of you agree on the answer. Should be right. Let's see. Okay, when you have 1 plus cos 2 theta, the formula is 1. What is 1 plus cos 2 theta? It's 2 cos square theta by 2 cos square theta rather. 1 plus cos 2 theta is it really? Okay, amazing. So 1 plus cos 2 theta is 2 cos square x, and similarly sin 2x, sin 2 theta is 2 sin theta cos theta, right? So these are the two identities I'll use. So I can write this as e power x into 1 plus 2, sin 2 theta will be 2 sin theta x by 2 cos x by 2. And denominator becomes 1 plus cos 2 theta is 2 cos square x by 2, right? And why did I do all of this? So that I can split it into two integrals. First integral becomes e power x into 1, e power x dx, obviously, divided by 2 cos square. So I can write 2 cos square as half, take the half outside. 1 by cos square is secant square. So sec square x by 2 dx plus 2 and 2 will cancel out. Integral of e power x into cos x will cancel out. You'll end up getting only sin x by 2 by cos x by 2. That's tan x by 2 dx. And here I'll use the integration by parts rule, right? So this is u into v dx will be equal to uv minus integral of differential of this e power x into differential of this. Differential of tan x by 2 is sec square x by 2 into half. Right? And you can see that's exactly what I had in the first term, right? So the first term, you don't really change it, right? If you know integration by parts, you know it's going to get cancelled out. So my answer is e power x tan x by 2 plus c, right? So absolutely, it's a question from, I think, from your CBSE books. Most of you are pointing it out. Good if you remember. Yeah, I know. Most of you will probably remember this as a direct property. I know that, right? I mean, e power x into fx plus f dash x, right? That's the way that you remember it, right? So it becomes fairly straightforward. Okay. Okay. A little more from Trigo. Let's explore trigonometry a little more. How about question number 8? About question number 8. Yeah. The thing is, Siddhant, that जब आप 12th में पढ़ के 2 महीने बाद पढ़ोगे तो आपको वो शॉर्टकट्स याद रहेंगे, बट फॉर लाइफ you should remember integration by parts, because even if you don't remember that formula, you can derive it for yourself. Right? That's what I do most of the time. Right? I don't remember every single specific formula, but if you remember the basic stuff, calculus is very easy. So 8th question, guys. Good for you, man. I think we all understand what you mean when you're saying that you're in 12th. Everybody else has passed out. Result आ गया है. When they know more in 12th. It's not a very hard question, guys. You should be able to figure it out. Actually, might be a longish question, maybe. Because there are so many powers. It might be easy but tedious. Should I do this? Should I attempt this question in the exam? देखते ही लगेगा लंबा है. Maybe mark it for later. Come back to it if I have time. Otherwise, find easier questions to solve. Right? So that's ideally the thought that should run in your head. At least for question number 8. I mean. Clearly, there's an advantage in being a student who's pursuing class 12th. Integration तो tips पे लग रहा है. What about the rest of you guys? छोड़ देंगे क्या question को? Is it that hard? I have integral of cos cube plus cos power 5 divided by sine square plus sine power 4. Right? The substitution here is very, very easy, right? I can see that I should ideally be putting let sin x be t, then on differentiating this, sin x का differential होता है cos x. Cos x dx will be equal to dt. Right? So clearly in the numerator I can take cos cube common. So I'll write that as cos square x into cos cube common लेंगे तो something into cos x dx कर देंगे. Right? This becomes, that's why I wrote cos cube as cos square into cos. Right? Because I wanted to make cos x dx. And then cos cube common लेंगे तो 1 plus cos square अलग से आएगा. And my denominator is taking sin square common, 1 plus sin square x, right? And now if you substitute, this becomes integral of cos square x, right? If sin x is t, cos square will be 1 minus sin square, so 1 minus t square into 1 plus cos square, right? So 1 plus this will be 2 minus t square into cos x dx, which is dt, divided by sin square x, so t square into 1 plus t square, right? And so it's fairly obvious what the substitution for this is going to be, right? You want to split into, use partial fractions at this point, right? So that you get some, you basically want to write this as, since the numerator has a degree of 4 and the denominator also has a degree of 4, you'll have a constant a plus a constant divided by t square plus another constant divided by 1 plus t square, equated to get the constants a, b and c, and then apply integrals, because when you have 1 by t square ka integral, it will be equal to 1 by t, right? Minus 1 by t, right? And what about integral of 1 plus t square dt? That will be equal to 1 by a tan inverse t, right? So you, I mean, even without doing it, you can see that it should be a constant. So constant ka integrate karenge to t आएगा. b by t square will give me minus b upon t, and here I'll get c into tan inverse t, right? So look for this form in the option choices. That's the advantage with having options, no? I can look at, very quickly scan the options and see, okay, what was t? T was sin x. So I should have sin x in amongst the options. If I look at options a, b, c, d, सब में sin x शुरू हो रहा है, okay. I should also have minus b upon t. I should also have a 1 by t, right? So I should have a 1 by sin x. So sin x to the power minus 1. I have that there. I have that in option C, okay. Right? That is there in 1 by t is t to the power minus 1. That's sin x to the power minus 1. That's there in option C. And you also have tan inverse sin x. That's also there in option C. So you basically can mark option C with a degree of, you know, you won't be certain because coefficients नहीं पता है आपको कि बिल्कुल सही है कि नहीं, but it seems likely that option C is the correct choice, right? So I'll leave you to try this out. I think the option is not option C, right? That's why this question is a little confusing. I think the answer is option B. Let me check it out. Yeah. By the way, Arushi is asking how A. Are you asking me about this A? Why A? Yeah. Okay. So the logic here is that, remember, numerator has a, if you have fx by gx, right? If this is of degree 4, it has a degree 4, right? Square means degree will be 2 plus 2. You'll have t power 4, correct? So numerator has a degree of 4 and denominator also has a degree of 4, right? So when you split this, ideally into partial fractions, you will get a constant term. You'll probably want to write this as, you'll probably want to write the numerator as this plus or minus something, right? Remember the other thing, you can directly write it as a upon, you know, if it's g into h, let's say, right? So you can directly write this as a upon g plus b upon h. You could write it this way if the numerator has a degree which is less than the denominator. If it's not of a smaller degree, if the degree is the same, you'll also have to get a constant a first, right? The logic here is, क्योंकि numerator और denominator दोनों degree 4 के हैं. Remember, question number 1 had numerator with degree 0, denominator with degree 4, right? So you could easily say there won't be a constant term. But there will be a constant term a when numerator is also degree 4, denominator is also of degree 4. right? Does that make sense? Anshuman, Arushi, you guys who are asking me this question, does that make sense? Why will I get a constant A? Because both numerator and denominator have degree 4. Same degree है, तो सबसे पहले degree वाला term cancel करोगे, and you'll make sure that partial fractions get supplied only at the point where numerator has a degree which is smaller than the denominator. Only then partial fractions will make sense. Is that clear? Why will A come? Only when degree is the same. Otherwise, you won't need an A. Otherwise, you don't need a constant. Right? Cool. Okay. Let me spend another 5 minutes. So, thoda sa delay hoga, extend ho raha hai, but I think this could be useful. Let's maybe look at some definite integrals. Yeah, I know you must have. Everything that I'm telling you is something you already have learned at some point or the other. Yeah, okay. Long division, yes. Okay, how about 14th? How about question number 14? Oh, typo, guys. There is a typo in this question. It's not mod x into log, it's mod x plus log. There you go. Siddhant, hazir ho. It's mod x plus log 1 plus x over 1 minus x. So make sure that you make that correction. It's log x plus, sorry, mod x plus. It's mod, it's not GIF, it's mod. Is it? Yeah. Wait, let me look at this guy. It looks like a GIF, right? Yeah, that's actually GIF. Wait, that's GIF. Let me write the expression here again. Sorry for the confusion. Question is this: integral of GIF of x plus log of 1 plus x over 1 minus x over the integral over the range minus half to plus half, right? This is greatest integer function. I hope you remember the greatest integer function. That's right, Siddhant. Definite integrals में सबसे ज़्यादा used property वही है, odd even. Should figure it out. Right? Is this odd or even? Is this odd or even? Because if it's odd, the integral will become 0. If it's even, it will be 2 times the half integral, right? Half the range at least. Is this odd or is this even? How do you check odd even? Is the answer 0? Is it? I'll wait for your friends to decide, Anshuman. Correct. So you check, no? What you'll do is you'll check, right? If this is fx, right? What is f of minus x? Log 1 minus x upon 1 plus x, right? It's not the same. Is it You can see that this is the inverse. Inside you have the inverse. So I can write this as log of 1 plus x upon 1 minus x to the power minus 1. And that minus will come outside. It will become minus log of 1 plus x upon 1 minus x. So f of minus x is equal to minus fx, which means this is odd. And if it is odd, then this integral will be equal to 0. Right? Okay, first thing is done, right? First part of the question is done. Easy. The difficult part is done. Now comes to the easy part. You have greatest integer function. I hope you guys remember the greatest integer function. What does the GIF of x mean? GIF of x means that it returns the greatest integer value that is less than x, less than or equal to x. Right? So for example, GIF of minus 3.5, sorry, GIF of 4.56 will be 4. It will return the integer value which is less than x. Greatest integer of 0.3 will be 0. But what about greatest integer of minus 4.7? Remember, it will be negative 5. Similarly, greatest integer of minus 0.32 will be equal to minus 1. Right? Now, if I remember this, then I look at this integral and say, okay, GIF of x depends on where am I integrating, right? Because the GIF is actually going to give me an integer value and successive values of x. What does integral mean? You're basically putting successive values of x. So successive values will give me the same GIF value. So I basically split this into integral of minus half to 0 GIF of x dx plus integral of 0 to half again with GIF of x, right? So when x lies between minus half to 0, take values, no, minus 1 by 2, then minus 1 by 3, then minus 1 by 4, then minus 1 by 5, and so on and so forth till you reach 0. For all of those values, the GIF will take minus 1. And for positive values, from 0 to, you can see 0.3 पे भी 0 है, 0.2 पे भी 0 होगा, 0.5 पे भी 0 होगा, which means at all of these values from 0 to 1 by 2, GIF of x will be 0, which means the integral itself vanishes, right? So I'm left with this. So negative of integral of dx will be x, and you'll substitute minus 1 by 2 to 0 means first put 0, 0, then put minus 1 by half, it will be minus half. Answer is 1 by 2. So the answer, sorry, it was minus 1 by half, right? It will be 0 plus half. So the answer is minus 1 by 2. Is that there in the options? Yeah, that's option A. Good. A lot of you guys figured it out. That's pretty cool, right? Which means you know at least how to work with GIF. That was the challenging part in this question. I'm trying to challenge you as best as I can. Okay, one more question and we'll split for the day. Let's look at something which is even more difficult, even more different at least. Okay, let's look at area. I like this. Question number 18. Question number 18. The area of the figure bounded by two lines and two curves, fx and gx. Find the area bounded by two curves, two lines and two curves. थोड़ा सा to solve this kind of it's a very very rare question. इस टाइप का क्वेश्चन आईपीएम वगैरह में नहीं आता है. इतना स्पेसिफिक क्वेश्चन एमसीक्यू टेस्ट में नहीं आता है, right? So I think this is fairly rare, but still I thought it's a question that most people face trouble understanding. Yep, this requires graph. Yep, that's right. Siddhant is absolutely right. Right? अगर आप question पढ़ोगे, it area of the curve means you need to get a graphical interpretation before you start the question, right? So I need the graph of sin x, right? And remember the question asks me to find the area bounded by the curves and two lines x equal to 0 and x equal to pi by 2. So pi by 2 is here, right? So figure थोड़ा सा अलग बना लेते हैं, right? So this will be sin x, right? This is 0, this is pi, and this is 2 pi, right? तो obviously ये वाला portion तो irrelevant हो गया मेरे लिए sin के अंदर. Similarly cos का, it starts from here and goes down. Oops. And this is what the cosine looks like. It's like the sine curve phase shifted back by pi by 2, right? So you can see that this is going to be pi by 2. This is the line x equal to pi by 2. This is the line x equal to 0, and this is gx equal to cos x, and this is going to be fx equal to sin x. Right? Can you see this? So you want the area of the region bounded by the curves and the two straight lines, which means you want this region. Right? And clearly, when you have two curves and you want the region bounded between them, you do upper curve minus the lower curve. But then that changes after they intersect, because what was up was cos till they became equal, and then after that what was up is sine, right? So, and where does this happen? When is sin x equal to cos x? The trick is to know that this happens at x equal to pi by 4, right? Sin pi by 4, sin 45 is 1 by root 2. So is cos 45, right? So this point will then be pi by 4. So what I do is the integral which I want will be from 0 to pi by 2 can actually be written as integral of 0 to pi by 4 plus another integral from pi by 4 to pi by 2, right? And when I'm integrating from 0 to pi by 4, the curve above is cosine. So it will be cos x minus sin x integrated with respect to dx, plus the second curve, the second region from pi by 4 to pi by 2, the curve that is above is sin x. So now you'll say sin x minus cos x dx in the second region, right? So what, yes, most of you are right. Siddhant is right. You can see that it's symmetrical, right? And if it's symmetrical, you can actually calculate only one region and not the other, right? But yeah, I mean, it's not a bad idea to check both of them, right? So if you calculate, ये वाला ही calculate कर लेते हैं, into 2 कर लेंगे, right? So you can think 2 into this integral 0 to pi by 4 cos x dx, right? In fact, let's forget this. Let's just integrate. Cos x dx का integral होता है minus sin x. Sorry, होता है sin x. और sin x dx का होता है minus cos x. So this will become sin x. This will become sin x plus cos x from 0 to pi by 4. What I get is 2 into sin pi by 4, 1 by root 2, plus cos pi by 4, also 1 by root 2, minus sin 0, 0, minus cos 0, 1. So my answer becomes 2 times 1 by root 2 plus 1 by root 2 will be 2 by root 2 minus 1. Cancelling it out, you'll get root 2. So 2 into root 2 minus 1 is the answer, right? That's option A. Yes. Yeah. Okay. So this was a nice flavor of questions we did. We did a lot more from differentiation because in an exam, I think the way I approach the session is the way you should also approach your actual test, which is that differentiation is easier to work out. So you'll probably want to pick out those questions first and attempt those. Integration, if it's definite integrals, much easier to work with because you know odd even wala funda, you know that definite integrals can also be solved much faster and option choices will help, right? And even if it is indefinite integrals, make sure that you take a look at the option choices, because you can get a hint on how to proceed, because now you have some expressions given over there. You can back sort of engineer the answer, or engineer the approach at least, right? So guys, please try the remaining questions. There's enough practice that I'm leaving you with today. Well, that's all I have for you guys today. I hope you enjoyed this session. I'm not sure you enjoyed it, but I hope that you liked it and will make best use of today's session. It's important both for IIM Indore and DU-JAT. I'll be practicing this. I'll see you, most of you guys, I hope to see tomorrow at 6 p.m. That's the WAT session for IIM Rohtak. And we'll pick it up next week. Yeah. All right. Thanks, guys. See you tomorrow. Have a great evening. Stay safe and stay indoors. And thank you.